This place will seriously blow you away. I'm inside an advanced wind tunnel testing facility. Now, you might have heard of places like this. They're normally used to test the aerodynamics of things that move very fast, like aeroplanes or Formula One cars. But I'm no Lewis Hamilton, and this channel is about things that don't really move at all. So what am I doing here? Well, places like this are actually critical to the design of some of the world's biggest and most impressive buildings. Skyscrapers.
All of the world's tallest buildings were conceived and developed using wind tunnels. They're essential to predicting the effect of wind loads, proving that complex architectural ideas are actually doable, and ensuring that people don't get swept off their feet. RWDI is a global leader in this particular field, and they've invited me along to their world-leading test site and model workshop for an exclusive visit. Their wind engineering teams helped build the Burj Khalifa, the Petronas Towers, Shanghai Tower, and many, many more buildings. So how does this place really work? Well, sit back, strap in, and get ready for a tour of this incredible state-of-the-art building. It certainly promises to be a blast. Now, if you were planning to build a new super tall skyscraper, where would you start? Well, obviously there's a great deal to think about. You'll need a lot of material, a huge pile of money, and plenty of talented people to design and build it. There's also the location. A bustling city like Dubai, Kuala Lumpur or Shanghai would be a wise choice. Then you've got another critical factor that has to be considered, one that becomes ever more important the higher you go. How the building will behave and respond to high winds.
It can be a difficult thing to measure, requiring cutting-edge technology, the kind of which I'm about to see in here. Where is this building, this facility that's enabled so many of our iconic skyscrapers around the world? Am I in a sun-kissed city across Asia or the Middle East? Well, no. Today I'm somewhere a little less exotic.
That place would be Milton Keynes, a city about 50 miles north of London, which is home to concrete cows, far too many roundabouts, and this epic wind tunnel test centre.
We're standing in front of what looks like an aeroplane jet engine very terrifyingly. How does this thing work? Is it basically just pulling in huge amounts of air and forcing it through a tunnel? Is that I simplified it too much?
That's perfectly correct, Fred. Yeah,
Right.
we pulling air, and we have 3 different fans, and they can direct the wind either to this side of the tunnel or either to the other side of the tunnel. And the reason is just about efficiency. So we can, with tunnel test on one side, we set up in the other side, and vice versa.
I came here today knowing you were going to put me in a wind tunnel and test it, but now having seen the size of the fan, I'm a little bit scared. But you've been in a wind tunnel, right?
No, I've been before. I've done it before.
You're still here.
I'm safe. You're
trying to reassure me, but that still like a really big fan. So.
Now, before I find out for myself just how powerful this machine really is, it's important to explain what sort of stuff is supposed to go in front of it.
Basically, the teams here create models of buildings, iconic buildings, in this case, the UK's tallest building, the Shard, and then put them on this turntable at the end of a wind tunnel. Wind is blasted down that space behind me at varying degrees of speed and pressure onto this model. Loads of sensors inside the model then pick up and collect data on how the shape of the building, how the form of the building is responding to those different wind speeds, those different wind pressures, and they feed it back into design teams so they can shape and make decisions about what a building should look like. And it's fascinating to think that almost every tall building you look at, almost every skyscraper in the world, would have been through a process like this to make sure it works before it gets constructed for real.
So why is that process so critically important? Well, if you don't put much thought into wind loading and aerodynamics, it could cause major issues during construction and operation, and you'll miss out on some big benefits.
Why is it so critically important that tall buildings go through this testing?
Well, we can think initially of safety. Safety is definitely a crucial aspect. The second main aspect is carbon footprint and cost. So potentially using wind tunnel test, if there are no particular crosswind response, you can optimize the design and you can potentially save around 25 to 30% of the embodied carbon. We're looking at the facade and the structures.
I want to know, how windy can this get?
Obviously in a wind tunnel we cannot get the same speed that you have in the real world. So it's everything about scaling. This one can reach 16 meters per second, here at the top of the tunnel. Obviously, in reality, you're going to have a higher wind speed, so we need to scale up everything.
So, what does that really feel like? Well, there's only one way to find out.
Now, these building models are really put through their paces in these wind tunnels, but it's hard to see on video exactly what that simulation looks like. So, to try and convey to you what these wind speeds really feel like, the production team have decided to put me in a wind tunnel. The croissant fared remarkably well, didn't it?
So, by now, you might be thinking that a career in wind engineering sounds pretty uplifting, but what skills would you need to do that kind of work? Well, to be honest, if you find mathematics a breeze, then you're probably at a bit of an advantage. But if you're not a big fan of maths and want to hone your skills, then take a look at today's video sponsor, Brilliant. It's a great way to develop critical thinking, learning a little bit more each day whenever you have the time. Take their measurement course, for example, which will teach you the essentials of geometry. You'll learn all about how different shapes relate to each other while applying visual problem-solving techniques. And with over 70 courses across a multitude of other subjects, Brilliant has plenty to get your cogs turning. To give it a whirl, you can try everything Brilliant has to offer for free for a full 30 days. Just visit brilliant.org/the B1M, click the link in the description, or scan the QR code on screen right now. You'll also get 20% off an annual premium subscription. Now, I never thought I'd say this, but let's get back to Milton Keynes. Before we go any further, we should point out that using wind tunnels on buildings is not a new thing. Researchers have been doing wind experiments on replicas of skyscrapers, like the Empire State Building, since the 1930s. And wind tunnels have been contributing to the actual design of tall buildings since the original World Trade Center was conceived in the 1960s. As skyscrapers have gotten not just taller, but more architecturally ambitious, ensuring they can withstand high winds before they break ground has become serious business. Using these tunnels and models, architects, developers, and other companies can really understand and even visualize how the wind will affect their building.
What's also really cool to show you is the smoke and laser test, which I want to dub the rave test because it looks really, really cool.
As the rave test clearly shows, it's not just about what wind does to a single building. You've got to look at the bigger picture as well, because planners also have to think about what would happen to the surrounding environment when a new structure is added in. To give you just one example, the wind effects caused by London's new skyscrapers have become a pretty big talking point in recent years. And it's generated quite a lot of work for RWDI, something that's plain to see on this incredible model of the City of London that they have on display.
Wow, look at this.
Yeah, I mean, everything in red is something we've worked on. That's been either built or approved by the city.
Wow. All the red is stuff that you guys have been involved in.
Yeah.
Goodness me, it's the most of the city.
We've done a decent amount, yeah.
So why is it important to understand not just how an individual building responds to wind conditions, but also how they can affect the environment as well? Why does that matter?
So whenever we're designing a building, we're wanting to consider not only if the wind environment is going to be safe for a person walking around the building, or indeed users of the building on higher levels, but also if it's going to be a comfortable and just nice place to be around. So when we've got a new proposed development coming in, we want to make sure that not only the wind conditions on that site is going to be a nice place for everybody, but also it's not going to impact the surrounding area as well. So we're wanting to make sure that everybody is happy to sit outside maybe, or walk from A to B, or wait in different areas and linger in those spaces. In the same way that when you're building a new building, you want it to look nice.
And I guess when you have this many tall buildings together like this, like you do in the City of London, that is really changing how wind is responding. It's almost creating a microclimate, right?
Yeah, exactly. The whole building aerodynamics, it's how they play into each other. So when we're testing this building, we obviously test it without anything just to see what already exists. But then we also test it with the proposed development with all of these buildings in situ. And then we'll also test it, in fact, with future buildings. So future buildings that are consented, just so that we can see what those future scenarios are going to look like as well.
So now we know what those machines are capable of and what they're used for, what about the actual building models? Where do they come from? Well, that would be another part of this same building, the model shop. Here, experts can spend months making detailed replicas of all kinds of structures, and not just skyscrapers.
This is a very recognisable building. Look at this. So we've done testing on this project for around 25 years.
What are these models made out of?
So this one is 3D printed, but we use anything that we can do to get to where we need to be. So timber, plastics, resin.
So talk me through the process here. What happens when a design team contacts you? What's the first step?
The first step is really understanding what the client needs. In this case, this was looking at the structure of the roof. Because for large span roofs like this, if you think about it, it actually has got the same profile as an aeroplane wing, and it's got updraft and down, the same way as an aeroplane. So in this case, we want to look at that and be able to inform the client what they can expect on their chosen design.
So you're talking to me about behind you, I can see like all these like different like architectural icons that you've modeled. It's amazing.
Yeah, I mean, we work on projects all over the world.
Yeah.
So we've worked on projects in Dubai, in China, in New York, in obviously the city of London, as you saw earlier, and a huge amount of those buildings. So there is everything sort of from the small to the large and everything in between.
So how many projects at once are you sort of working on here?
At the moment, we're working on probably sort of 10-ish live projects. We're working on things all the time. Everyone's always busy. And as ones are going out, we've got projects coming in, right?
Yeah.
So as the world develops, so does that work, so to speak.
Yeah. Getting to come inside a place like this has really been an awesome experience. You know, when you think about our skyscrapers, you think about the architecture, you think about the construction process, the cranes, the steel, the kind of core traditional engineering, but you don't think about places like this. And for me, coming here has really lifted the lid on an area of construction that most people don't think about or don't even realise exists. And these incredible people, these unsung heroes, are making sure that so many different types of building around the world are actually viable. They can actually stand up. They're making our skyscrapers possible. It goes to show once again the incredible power of this industry, the incredible array of jobs there are in this industry, and the amazing people that put so much into making our built environment happen.
This video was sponsored by Brilliant. You can learn more about that at the link below. Don't forget that we're inspiring the next generation of builders and wind engineers through our investment into Brickborrow, a fantastic LEGO subscription service. You can learn more and get started today over at brickborrow.com.
And as always guys, if this video blew you away and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.